Test, test. Hey guys. So. Okay, so yeah, had a great panel. I'm going to talk to you guys a little bit about a serverless platform that that our company has been working on that we're open sourcing, right? So the kicker to this is the original speaker for this just got sick and went home about an hour ago. So I was not supposed to give this presentation. This is his background. But I am Bryce, right? And I will be giving the presentation on his behalf. Yeah, so yeah. So you're still getting the content, albeit, yeah, so Bryce. This is me. So I used to work at Homeland, and I run the unclassified SOC there, incident response and focus operations for a while. So a lot of endpoints and a lot of, nation state type tracking down and getting them out of the networks, right? And then I worked at NSA for a while, and I did offensive stuff there. And then I came to Adobe and built up a red team in the digital experience business unit down there in the Lehigh building. And now I am leading stage 2 security, and we test stuff like pen testing, and we teach some courses at Black Hat or privately, and then we're kind of spinning up on the hunt front over the next year. So really the genesis for this utility was kind of the trying to get most of the mundane stuff we do off our plate and using some of the latest serverless cloud technologies that are available. So and I just want to state Michael Butler, who's our VP, wrote the tool and did the research, so all credit goes to him for this. So but yeah, when we're doing red teaming or we're trying to assess our infrastructure for an assessment, there's a lot of like recon and enumeration type stuff that we spend time on. And that's boring. We want to get to the fun stuff, the hacking stuff, right? So back in the Stone Ages, like back when I was like in, I don't know, middle school or whatever, you might have like a laptop and you would use netcat, telnet, or scripts to kind of enumerate a server. And kind of the pros to this is it'd be really easy, right? You just grab your laptop, you could walk into a client site, plug it into their network, and start to, do a pen test or assessment. But it's really no scaling, so as your pen testing team grows or red team starts to grow, that becomes problematic, and it's really not automated, and so everyone's processes are a little bit different, and you may start missing stuff. So then, much better, right, is Nmap came along, and really Nmap kind of unified a lot of the pen testers in the sense that you had a standardized tool, and it also had this scripting engine, so you could build more capabilities on top of it. So you could walk into a client site with a laptop, you could pop up an Nmap, and it would go through and scan the network and say like, okay, this server has port 80 open, that means it's running a web server, and this server has 25 open, so that's a mail server, and we ran this Nessus script against it, so we know that the mail server is running an out-of-date version and is vulnerable to maybe like this type of CVE or something like that. So that was much better, but still really limited. Doesn't really scale past one person very well. And then these tools are really cool. So they're really progressive. Layer and Faraday both work a little bit differently in the design. But basically, they enabled a single pen tester or multiple pen testers to kind of have additional servers that they could task to do scanning tasks, like essentially wrap around Nmap, and then collect that data in some type of centralized database or control node, right? So this is cool because you get a little bit more scaling, but some of the things that were bad about this were like the cons is it was like hard to set up. Like you had to spin up servers or get servers, and you had to install the software and configure it, and then you had to make sure they were able to talk to each other. And your workers, you might have like static IPs on the internet. So, and once maybe a blue team discovers what your IPs are, you'd have to stand up new workers, and there's really, I mean, you could wrap this around like using a tool like Terraform or something like that to try and rotate these worker nodes, but that's not really built into these tools. They don't enable you to do that. But Layer and Faraday, they're good tools, but they're still, the biggest issue is like, just takes time and effort to get them set up, right? And they're kind of static. So we really wanted to build something that was more modern, right? Something that's leveraging cloud technologies, right? The cutting edge today. And so we built this tool that uses serverless technologies. So in AWS, you can essentially, which is Amazon's cloud, you can essentially write scripts that will accept inputs and run and feed data back, right? So, and the great part about this is, you know, it's very easy to spin up and spin down. So if you want to scan a target really quickly, and let's say there's like 1,000 scripts or checks you want to run against the target that can thread out to 1,000 different Lambda functions, which spreads across Amazon's cloud. They can collect the data and then bring that back to you in a centralized repository. So, right, so, I mean, there are some cons to this way too, but so this is the approach that we took with this tool. So, so serverless is, you know, really the future, right? As far as cloud technologies go. I mean, I think Lambda is starting to enable developers to have a few kind of common workflows, right? You know, one is kind of using it as glue so they can stitch together data there in other repositories. And another is to kind of scale out via like a RESTful API. So, and when you're talking about cloud, you know, when we're talking about the evolution of cloud, you know, back in the day, a company might have a data center, and then they decided, oh, it's really costly to run our own data centers. Let's use a colo. And what it really was a colo is just somebody else's data center, which a data center that you're sharing with multiple companies. And then cloud providers came along and said, look, that's still pretty difficult to get servers in, to get them racked and up and running. Why don't we just have some type of self-service portal where users can come in on demand and spin up VMs whenever they want? That's kind of where ISaaS, or infrastructure as a service, came from. And that enabled kind of this revolution of cloud to start to take off. Now developers could just click a few buttons and have a bunch of servers, and they could have their different stats they need, the right CPU, the right memory, all that, and they don't have to go through a centralized, you know, data center operations team or wait for stuff to be racked at a colo. But then, you know, taking it a step further, you know, when infrastructure as a service and these cloud providers, the VMs, really abstract away the hardware, so you don't have to rack hardware anymore. But cloud providers said, we can do this even better, right? We could abstract away the OS. So you can just write developers, you can just write your app, and we have like a standard platform, and you can just develop that app on our platform. And then serverless really is functions as a service, right? It's not abstracting away the OS, it's also abstracting away the runtime. So you just write a Python script, and you make sure that the inputs come in correctly and go out correctly, and then it takes care of all the scaling, spins up, spins down, and extracts everything else away. And the most common for this is AWS Lambda. Azure has functions, and GCP also has a serverless solution. So all of the major cloud providers, Amazon, Microsoft, and Google, have solutions here. Right, and so really, as you need more of your code to spin up, AWS takes care of that and scales up your application, and then it runs on top of their shared infrastructure of servers, so you don't need to maintain that. And really, you're only paying for the time that your functions are executing in AWS. So you're going to reduce your cost a lot. Rather than having a bunch of servers or VMs sitting out there waiting to scan something, this will only charge you when you actually go to collect data against a target. Right, so serverless, way more scalable, way more cost efficient. One of the side benefits of kind of doing it this way is when a serverless function executes inside of AWS Lambda, it's gonna, and it makes an outbound request to maybe a server on the internet, it's gonna do so out of AWS's pool of IP addresses, and it's gonna be automatically randomized. So there's really no static IP that you have to worry about, and these net blocks are very large, so that it'd be very difficult for like a network defense team to block those entire network ranges. And you know, Very powerful, right? All right, but what could we really, like, as a red teamer or a pen tester, what could we really do with all that power, right? So we can do faster port scanning, we can do more subdomain brute forcing, you know, we can extend out our scripts, and we can take screenshots of web servers and more, right? So I'm just going to walk through some of the AWS's serverless technologies that we leveraged when building out this utility. So, these are the services that it uses, and then we'll talk about each individual one, right? Lambda, which is what I've been talking about, is functions as a service. It's kind of similar to like a microservice or like scripts for AWS. So this is where your actual code is going to run, and generally is going to be, you're just going to be focused on the code you want to execute. And super cool hacker tags. Yeah, okay. So how does Lambda actually get executed though? So typically you're going to need some type of trigger event, right? Maybe someone calls an API, like a RESTful API, and that will send the inputs into Lambda, and then Lambda will execute the script, right? Or maybe there's a queuing system. SQS is a queuing system we'll talk about. So maybe a message gets pushed to the queue, and then Lambda functions or Lambda scripts process each one of those, and then take those messages, and you know, maybe there's a queue for when you upload an image to a website queue, and then as the image needs to be converted to a certain resolution or size for the website, Lambda functions come and execute Python code, which format it, and then those get stored in maybe like an S3 bucket for storage. So that's kind of, there's got to be a trigger there, generally speaking. And then usually when you're done processing the data through Lambda, you want to store it somewhere. So generally you're going to store data in a object storage system like S3, which is a simple storage solution by Amazon. And kind of think about it as like an unlimited FTP server. If you've ever used an FTP server and you just like uploaded a bunch of files, but then it ran out of space, right? Like this is trying to solve that problem for you. It's trying to let you programmatically store data in Amazon's cloud without you know, ever running out of space, and without you as the programmer ever having to worry about, you know, data availability type concerns. But sometimes, you know, you just don't want to store files. You actually want to store the data in a format that is that's going to be queryable, right? You want to format the data, and you want to kind of, you know, do SQL statements again. SQL statements to pull the data and join it together. AWS recently announced Aurora Serverless. So this is basically like an auto-scaling MySQL fully managed service. So you can, just as you would for a normal web application, store the data in a MySQL-like database, and then retrieve the data. You could also use a solution in AWS like DynamoDB, but it would cost a little bit more money. So Aurora Serverless Edition is pretty attractive these days. And then you really, if you're going to write something and it's going to enable you to go scan other servers, you probably just don't want like anybody just to like browse to your web app and be able to use your Lambda functions to scan servers, right? So we want to have some type of single sign-on system or some type of authentication to ensure you are who you say you are, right? And Cognito, that's what it's used for. So this is like an AWS OAuth service, and it enables us to authenticate you. And frequently, this is used in combination with, you know, like if you go to a website and it's like, hey, do you want to create an account, or do you just want to use like G Suite or Facebook or your other accounts? Cognito can handle that type of authentication as well on the back end and enable developers to kind of abstract away a lot of that code. So SQS is AWS's queuing service, right? So think of it kind of like as RabbitMQ if you've ever used that, or basically when you have a task and you want them to get processed, but they may take some time to get processed, you might want them to get queued up. So you would send a message to SQS, and then maybe as Lambda functions come, they would pick off a message one at a time, process them, and and then format data and store it in Aurora or S3. So, big things is like when you sign up for a default AWS account, right? You just think, you get really excited about Lambda. So I was sitting on my computer one night thinking like, oh man, I can write anything and I can just scale it as far as I want. So I was just thinking, okay, well I'm just gonna, talk directly to SQS using the API, and then I'm gonna have Lambda pick off messages off the queue. And then I did some speed testing, and I realized, like, this is not going nearly as fast as I thought it was going to go, right? So the thing is, with a default AWS account, they kind of put guardrails in place to make sure that you're not going to, shoot yourself in the foot by charging up a huge bill. So by your default, when you sign up for an AWS account, you can really only kick off 300 concurrent Lambda functions at a time. So you can put a support ticket in to raise that limit, but that's what I discovered when I was trying to, play around with this a bit. But SQS, there's still going to be things that are going to take a while, and maybe you just don't have enough. You've hitting your limit on Lambda functions, so this is a good place to move the data from point to point, process it. And SNS is more like real-time notifications, right? So, if you want to push out alert to someone's mobile phone, right? Like maybe as part of some two-factor authentication type service, you could use this to push by email or SMS to a user's phone. So, and also you can use this just to stitch together between services, but you just have to realize the difference between this and the queuing service is in the queuing service, you won't lose messages. They will queue up and then be processed 100%. In SNS, if the service you're trying to push data to is not ready, it will just drop the request, and so you will not get that processed, right? So if you're hitting your max number of Lambda functions, like I'm already running 300, then those requests are just going to get dropped. And then API gateways are really the RESTful API portion. And this is how you're going to use Lambda to stitch together technologies, right? So to get either your other information systems or even internally talking back and forth. And this basically creates a RESTful API where you can query and have some type of action taken in the Lambda function. All right, and then tying that all together, right? Like this would take you a lot of time if you wanted to go through and set up every service so that you could run this tool. But luckily, AWS has a service called Cloudformation, right? And in Cloudformation, you can have a template, and if you load this template up in Cloudformation, it will configure all the rest of these services so they talk together in the way that you designed, kind of as you're architecting or building the system. And that way, you can just hand this single JSON file to anybody, and as long as they have an AWS account, they can spin up the same infrastructure in virtually the same format. So really what this tool is, which is called Hindsight, is a Cloudformation script that you would download from our GitHub. You would just load it up, and then it would take care of configuring all the rest of those services so that you don't have to worry about any of that. Right? And just kind of putting this together, Cloudformation spins up all these other services. That's that first box. And then when requests come in, they come into the RESTful API, but we don't want just anybody to be able to execute our Lambda functions. So we go to Cognito, which is that little credit card icon, and to make sure that you are authenticated with single sign-on system. And then we can use either SQS or SNS to push the messages out to services. And then if we want to process data, we use Lambda to process it. If we want to store it in a way that's easy to look up, like a relational database, we push it to Aurora Serverless. Or if we want to store the data for long-term, like images or things like that, we push it to S3. And we can have authentication on all these backend services, so there's no way to get to the data except for going through Cognito. Right, and we call this tool Hindsight, right? So mostly because in hindsight, I really wish we had this tool 5 years ago. So, what is it? It's a 100% serverless platform. You deploy it via CloudFormation template, and it currently just does enumeration capabilities, but we're kind of adding on features as we go. There's been a Star Wars theme to this presentation, if you haven't noticed. Right, and it's really easy for you to deploy via the CloudFormation template. Really just, you got to go to the CloudFormation service and upload the JSON file, but it actually is rather complex on the back end. We're using step functions inside of AWS to kind of walk down a logic tree of which enumerations to kick off based off of what information we're getting back from the target, right? So we're kind of using the information like, is port 80 open? Okay, if so, is the HTTP service running on that port? Okay, if so, okay, check for these other things. Run these other Lambda functions. And then we're kind of doing that for multiple services. And we've built out a UI for this, so it's easy to use, because if it's not easy to use, it's more just a project, right? So, but it also has the API portion. All the services kind of talk back and forth through the RESTful API. Okay, great. So we're working on making it more extensible as we go, and that really just means adding more Lambda functions to do additional enumeration to automate common pen testing and red teaming tasks. So the cost for running this really depends on what you tell it to do, right? So if you deploy the Cloudformation template, your costs are going to be very minimal, right? But then when you actually go to scan targets, then you're going to be leveraging all these services and storing data, and so costs will increase with time, right? So, but still should be pretty reasonable. Okay, great. So without further ado, I'm just going to show you the tool, if it's going to let me. Right, and this is what the tool kind of looks like. So after you deploy the Cloudformation template, you can browse over to this. You can, via the API gateway, browse over this Lambda function. When you first come here, it's going to ask you to log in. Your username and password are going to get authenticated against the Cognito service. So you need to manually go into the Cognito service and add a user, right, and password, which is pretty easy. Once you log into the AWS console, you just search for Cognito, and then there's a button on the side that says like users, and then you add a user, right? And then once you're logged in, you can create a project. So for example, in this project, I can just name it test 003. Right, I'm gonna flip over to this insecurely. Okay, so let's say there's assessment and we see a default Ubuntu page, right? So usually when we see these things, there's a reason that someone has stood up this server, and the reason is usually because there may be some type of web application in a subdirectory, right? So we might try and browse like /admin. We see like, oh, it wasn't found, right? But we can see we're getting a not found error, so it should be pretty easy to detect what is available, what is on this server and what's not. So instead of like manually trying to pen test this, right, we could just come over here and under test 3, click new scan. We can say like, hey, like check for all the ports on this target, and then if any of them are running HTTP or HTTPS, then go ahead and enumerate web content, like try to guess for common files and directories. And then you can put in a list of IP addresses, or in this case, we'll just put the single IP address so that it, yeah, just as a simple example, right? And like literally when we click submit here in this is going to go spin up a bunch of Lambda functions. They're going to go and pull data from this IP address right here, like port scan it using pure Python and Lambda functions, and enumerate which ones have web services on them, guess for files, take screenshots, and then return the results back here. And you'll see how long it takes for the results to appear, right? So we click submit, we click over the results, and it will take a second for those Lambda functions to move and store the data back in Aurora serverless. But generally speaking, and there we go, right? In a pretty rapid time frame, we can see, okay, port 80 and 443 are open. Here's the banner that we got back from port 80, so we can tell, like, hey, this is running Ubuntu because it's in the banner, and Apache. You guys probably, can you guys not see my monitor? And yeah, so you can kind of see that data there, right? So you know, nothing super groundbreaking, but really helps you automate the test, right? And then here it goes down and says, look, we tried /test on the web server automatically for you using AWS Lambda, and it returned a 200 HTTP code, meaning that the resource was available. And so then we tried to start guessing files underneath that, and we saw there's an index.html here. In addition, it took a screenshot of the default web server, so in case the web server has gone offline since you scanned it, maybe you kick off a big scan of a net block, and then you come back later and review the data. You could click here to see what that is. And really all that does is downloads a ping file from the S3 bucket using a signed URL, right? So when you so in a secure fashion. And really the website just says test, so that's all the ping shows us, is it says test. And I've lost my desktop. Okay, great. And we can do some type of like validation to make sure that the IP address that you put in isn't crazy, right? So it checks to make sure like the IP address you put in is actually routable across the internet and is not like a known DoD IP address or something like that. So not that that would ever happen, but just in case, you probably don't want to do that. So that's kind of the tool. Flipping back over. Right, so, and I just wanted to talk for a minute about how we dev the tool so that in case you guys want to do additional modules or whatnot, you'll be able to do that. So we're big fans of Cloud9. I was using Cloud9 for quite a few years, and recently AWS purchased them and integrated them into the AWS platform. So what it is it's like an IDE. So if you've ever used software like PyCharm for programming, it's like that, but it's all in the browser. So anytime you want to add more code or whatnot, you can just go back to the Cloud9 service, which is now inside AWS, and then that makes it a lot easier to dev the code, right? You know, there are frameworks out there to help automate serverless application deployments. They're popular, yeah, so yeah. And then the tool is going to be posted up to our GitHub. I was hoping to have it up today, but he got sick. So hopefully be up tomorrow. But that is the tool in the presentation, right? So we do trainings as a company and AWS and Azure exploitation, and then we're kind of integrating this tool into some of that training content. So is there any questions about the tool? Yeah, go. Cloud9? I mean, I like it, but I feel like for the things that we're building, they're really discrete in functionality, right? It's like you're creating this Python script and it's just checking for like a TCP port, or you're creating this type of Python script that's just pulling a banner, right? And I mean, I've used it to write more full feature stuff over the past couple of years, but like I'm more of a like hacker, red teamer by trade, you know? I'm not like a full-time developer. So if I was a full-time developer, I don't know if it has like as feature rich as, you know, like a PyCharm type solution. But I don't know, for things that I do, I like it because the code is always there. It's in a state that I know works. I can use it from any laptop. I don't have to have the endpoint device configured the way I like. And if I only have 5 minutes to code, I can go in there, make some changes, right? And then I can get back to what I need to be doing and then come back and forth, right? Or multitask in business meetings, right? So that's why I like it. But you know, PyCharm's great too, right? If you're doing Python. Yep, Wes, what's up? Yeah, so the question is, does it support internal VPCs? So there probably should have been a slide on that, right? Right now, the way it does run is it deploys inside a VPC. So the Cloudformation script does build its own VPC and deploys it inside of it. So I don't see any reason why you couldn't run this against an internal VPC. The only thing that might prevent you is the sanity checking on the IP loop box. So you just have to go in there and like remove the 10.0.0.0/8 from that list, and then you should be able to run it on the internal, right? So yeah, should work for you. So let us know if it doesn't. Yeah. Yeah. API gateway, is it still kind of pricey is the question. This is a great question. It doesn't feel like it to me. Sorry, I don't really know costs, so probably not the most responsible spender in AWS. Is there anybody who has a comment on that? I mean, I haven't run into any issues like that with crazy AWS bills when building this tool, right, and testing it. So, because I definitely pay those bills. So so I mean, for my use cases, but I can't speak if you were building like an entire platform and using API gateway to talk back and forth. I mean, I could imagine the cost could get higher, right? So, yeah. Wes, you have a comment? Yeah, they haven't yelled at me yet, right? Good question. Okay, so Bryce, how do you prevent Amazon from yelling at you, right? Yeah, so I've written a lot of offensive stuff and run from Lambda, right? And to date, I haven't received any complaints from AWS. So the only complaint I ever got was, hypothetically speaking, if you scanned a DoD IP address, which never happened. Scott. Yeah, I just know I use it for all this kinds of stuff, and we don't ever get any complaints. So, all right. Yeah. Okay. Yeah. All right. Let's talk more later. So, um, let's see. On the subject of this, there is like an AWS pen testing authorization form. So if you are pen testing targets that are hosted in AWS, you should be completing that form. They did modify the process so that like the root count has to complete the request for the form, which becomes problematic in certain environments where no one has access to the root account anymore. So, anyways, so there is a process there that's documented on AWS's website for pen testing other AWS systems, right? So, yeah. And then on Azure, their rules are a lot more relaxed. Like Azure, I think they did away with even having you don't even need to ask if you're testing your own VMs on Azure anymore. You only need to ask if you're pen testing the fabric of Azure, right? So, which they have like a bug bounty program for. So, and I don't know what the rules are in GCP yet. So, other questions, comments? All right, I do apologize. Oh, yep, back here. Yeah. I mean, okay, the question was, what about from the blue team side, right? I mean, you could definitely use this exact tool for blue team purposes, and you could even modify it to automate, like let's say you had like a, Splunky S instance, and it was kicking off, like tracking notables, or you had some other SIM, and it has alerts, right? You could even say like, hey, when hindsight you see this certain information, talk to this other API and kick off a notable or alert. Yeah, that's 100% possible, and in fact, may even be more useful on the defensive side than the offensive side, right? I far to say, if you're looking to get more visibility into your own infrastructure in an automated fashion, right? So I think that's a good call out, right? Thank you. Yep. All right, so this is a great question. So I know it's Python 2.7, right, is the runtime for most of the functions. We are using Amazon Lambda step functions as part of the design, right? I apologize, I don't really know how it works under the hood other than that. If you email Michael, his email is right up here. I'm sure he'd be happy to chat with you or answer questions, or he's in BSides Slack too, and happy to get you more details on that. But honestly, yeah, I didn't expect to present today, so I didn't look under the hood, right? So a ton. So yeah, no problem. So, but happy to get you answers. So, any other questions? Yeah, Scott. They cranked it up to 1,000, right? But I don't know. I wish it would be unlimited. How high did AWS crank up our concurrent Lambda limitations? So I don't know. I mean, we haven't really run into any worst case scenarios with this tool, like infinite loops or whatever. So I don't know, it seems pretty safe from our testing, but obviously you should test stuff yourself before you use it, right? If you're using it in an account that has high limits, right? So. All right, well, thank you guys for coming out. I'll be up here. I do apologize, Michael wasn't able to make it. He had to go home sick, and yeah, thanks, appreciate it. So.